Oh, yes, yes, yes.
All right. On your worksheet, you have at the top, we're going to check it. First thing, number 1, read for me the answer and the question. Cece.
What is the smallest part of an element that still has properties of the element?
Atom. Number 2, Emma.
Molecule. Smallest particle of a compound that still has the properties of that compound.
Molecule. Yes, that means number 3 is what?
Compound, a type of matter of a material or element.
Compound. All right, number 4. All atoms have the same number of protons. Now, if it's true, you don't have to answer anything more, but if it's false, you got to say why it's wrong. Luke Spence.
It's false because all atoms have different parts of different numbers of protons, and an example is only a carbon atom could have 6 protons.
Yes.
If any atom has 6 protons, it's a carbon atom.
If it's 7,
It's a different atom.
it's something else.
Yeah.
All right, number 5. Metals and non-metals are both good conductors. Riley. Why not? Ethan.
I put true.
False. Why is it false?
It's false because non-metals we use as insulators a lot of the time, and those are pretty much the opposite of conductors.
Yes, in other words, they're not going to pass electricity through them. They're not going to pass heat through them. Okay, so the non-metals are more of the insulators. They're the ones that aren't going to pass that through there. Number 6, is a compound simply a mixture of 2 or more elements? Explain. Cece.
Compounds, well, this is from the book.
Okay.
Compounds are not just simply a couple of elements. In the book it says the compound is not simply a mixture of elements, it is a new substance. It is different because it is different from the ingredients.
So in other words, it's a new substance. Okay? You're creating something else. Yesterday we saw a video where they had they took the sodium, which was poisonous, and then they put the chlorine in, and then he heated it. The heat made it into a new substance, and that new substance was salt, which wasn't poisonous. So it makes it into something else. Today you're going to see what happens when we mix things. Okay? All right. Today what we are going to do is, how can matter be described? How are we going to describe it? Okay? There's different ways that we are going to describe it. We're on page 16 in your book, 16 and 17. There's different ways to describe it. Let's have Christian describe Andrew. Now, I need to be more specific, and that's my fault in asking the question. Describe Andrew physically. Physically, okay? So in other words, you're not going to say he's funny because that's more of an emotion. You're going to talk about what you actually see.
Like blondish hair.
There, that's good.
Eyes.
What color?
Blue.
Okay? And that's describing. If you talked about his black shoes, because from what I heard from yesterday, his shoes are the same as his sister's.
That's what you know.
She told me when I was in her class. do you have Andrew in class? Yeah, yeah. He's got the same shoes as me. Random. Now, Christian, how are you different from Ryan? Physically.
I have a different color hair.
Yep.
Taller.
You're probably taller. That's good. Those are two things that are physically different. Okay? Now, today what we're going to do is we're going to be describing things, and we're going to describe them all different ways. Okay? Certain things that we're looking at. When you did Ryan, you said that you were taller than him. So all of a sudden you're talking about height. Okay? You talked about your hair color. Okay? So there's color, there's height. There's two certain ways that you could compare everyone in this classroom. Right, Austin? What do you got nobody else has?
Orange hair.
Orange hair? Well, I would have called it red, but yes.
My brother has that color hair.
So those are things. Now, I've got a certain little experiment that we're going to do. This is salt. Okay? So I'm not putting a whole lot. Well, it'd be a whole lot if you were putting it on something, but just a little bit. This is what? No, no. Sand. It's just sand.
Whoa.
Okay.
It was rice. Rice? Yeah.
Wow, that's some weird looking rice.
Now, I'm going to ask Kane, do I have about the same amount?
Yeah, around.
Okay. So there's about the same amount in each one. Okay. Next thing I'm going to do is I'm going to add water.
Water.
This is the one with sugar. Okay.
You mean salt?
Or no, this
That's
is sugar.
sand.
This is the sand.
Oh, looks like sugar.
It looks like it, but it's not. I'll put a little more in it just for the heck of it. Okay. And this is the salt.
Boy, that's different.
A little more in the salt. About the same.
Yeah,
Okay.
What are we trying to do?
Now.
Ooh, this is about to be crazy.
Oh yeah. I'm gonna
Salt water. It's gonna explode.
stir them both up. Stir that one.
We might have to go outside for it to explode.
Let's save the comments. Okay. Let me stir that one. What happened?
They're different colors.
Cece?
One of them is like a lot more blurrier water type, and the other one's like a lot more clear.
This is blurrier and this is still clear. What else? Austin?
I think the salt mixed in with the water and the sand just stayed on the bottom.
Correct. It mixed in. The salt mixed in, this didn't. Okay? They're both granule things. I put about, I asked Kane, he said, yeah, you put the same amount in there. So there's the same amount of sand in here, and if you were to look at it, it's all sitting on the bottom. Maybe you can see it that way,
Yeah. Oh yeah, I see it all.
okay? And here
It's nothing.
is nothing, okay? But who was it, Cece? You said this was blurrier over here? Why?
Because it mixed in with water.
It probably mixed in, okay? Now, The sand didn't mix in, did it? But the salt did. Those are gonna be characteristics that are different between the two, okay? So if something mixes in, that means it's soluble, be able to mix into it. The sand, it didn't, okay? If you mix sand in with water and you really stir it, it will move around in there, but it's not gonna hold. It'll settle back out. The salt, it probably won't settle out. Okay? All right, on the top of page 16 and 17, you have, it's like a big balloon or a big blimp is what it looks like, but it's a real colorful one, right? Four properties are shown. Check the one that you think allows the blimp to float in the air. Let's put a check on the one that you think is the one that allows it to float in the air. Megan, which one did you check?
The one that says lighter than air.
Lighter than air. Now, is it colorful? Yes, but that's not a property that's gonna make it float. Lighter than air, yes. Helium is lighter than air, and helium will rise. How do you know that? Huh? Yeah, you go to the store, you go get a birthday balloon for someone, or a get well balloon, or a congratulations balloon. It's gonna float. You're not gonna go into the house and it's just, limp, okay? If you blew it up with air, it would bounce around, but after you threw it somewhere, it would settle back down. Because it's the same as what air is. You're putting air in it, okay? How many of you have ever opened the, let's see, how many of you, put it this way, you have a refrigerator, okay? And you have a bottom door, big door at the bottom, which is your refrigerator. And then you have a door at the top. They have these, you may not have one. Door at the top that has the freezer. Mine at my house has the freezer at the bottom. I pull it out, and then I have the French doors that open up. But I also have another one out in the garage where I'll open the top, and it's a freezer, okay? Now, if I open the top part of that, and it's a freezer, what's the air like that's in there? Really cold, freezing cold, okay? This freezing cold air, when I open it, where am I gonna feel it? Somebody said it, where? Why my feet? It's up here, but I'm gonna feel it down there. Why? You're right. Why?
Because it weighs more than air.
You're right, in a way, okay? Hot air, what does hot air do? It goes up. And the reason it goes up is because the molecules are moving super fast. And since they're moving so fast, they need more space. Okay? So there's less molecules in there, and it goes up. Okay? Cold air, I mean, when you guys get cold, don't you sit there and you just like this? And when you're doing this, you're already doing it, Riley. You're sitting there going, because when you get cold, you're not gonna move that much. Before all this COVID stuff and everything, everybody used to bundle up and they would get close to each other because the warm air, the warm bodies, to keep closer, you wouldn't freeze as much. You watch penguins, they bundle up in a big thing, so when blizzards come, they're all bundled right next to each other, okay? Cold air is all compacted in. So in hot air, you may have, you know, in this big circle like this, you may have, we're gonna say, I'm gonna exaggerate on this the wrong way, but I'm gonna say that there's 50 molecules in here, okay? Cold air, they're all squished in, and there's 200, okay? So if you got 200 in here, is that gonna be lighter or heavier than 50? It's gonna be heavier. So that cold air, that's why that cold air sinks and goes down, okay? They also put on here, it has a pointed nose. Does it? Does this thing have, it does. Is that describing it? Yeah, there's not wrong, but it doesn't have anything to do with it keeping up in the air. Smooth surface. That probably has a smooth surface. It looks smooth. Okay, it's not real rough. These are all things that can describe this balloon. Okay, this space, this airship is what they call them too. Okay. Now, the first one that we are going to read about is color. Okay, Riley, go ahead and read about color on page 17.
Many solids and liquids have color. Some gases also have color. Color is a physical property of matter. Every solid, liquid, gas, and gas has its own set of physical properties. The physical properties of a material can be observed, described, and measured without changing the material. Some properties can be measured with tools such as rulers, thermometers, and balances. Color is very useful because you can determine the color of a piece of matter just by looking at it. And color often helps you determine the kind of matter you are looking at, or the state or condition of a piece of matter.
Okay, number one, it says describe the glass cylinder to the right containing a column of liquid. What can you learn from the colors? Kane?
You can learn that the colors don't mix.
They don't mix, okay. What else? If you were to look at it, is there more red or less red than yellow?
All colors look even to me.
Yeah, they're very close. They're about even. All the colors are even. Have you touched it yet? No. This color is one that you can just look at it. Christian looked at Ryan and said their hair is different colors. It is. Okay? It's something that you can look at and you can tell that there's a difference. In here it talks about where some of these properties can be measured with a balance, with the scale, with thermometer, all sorts of different measurement tools that you could use to measure things. And with color, do you need a tool to do anything with it? No, it's just from your eyesight, okay? Down at the bottom it says solid odium, iodine, is a dark purple, almost black. Heat turns it into a purple gas. Solid and gases, iodine, have different colors. So the solid iodine is dark, almost black. And the gaseous one when it turns into a gas, is a purple. Okay? Are they both iodine?
Yeah.
It's like water. You can have it as a solid. You can have it as a gas. As a solid, you can see it more. As a gas, you can't really see it. Okay? On to page 18, mass. We're going to talk about the mass of Ethan and Christian. Not trying to pick on you anyway. But Ethan, you're the smaller one. Christian, you're probably the bigger one in here. Probably between you and Liam, probably, as being the biggest. Mass, who wants to read? Cece, you've raised your hand too many times. I got to pick on somebody else. Allison, go ahead and read. Nice and loud.
Mass. The amount of matter in solid, liquid, or gas is called its mass. Mass is measured by using a balance, often using units of grams or kilograms. We often weigh objects to get an idea of their mass. But mass and weight are not the same thing. The weight of an object on Earth is different from its weight on Mars. But the mass of the object is the same on both planets. To find the mass of a solid, such as a toy car, you place the object on one side of a balance. On the other side, you place objects of known mass, such as grams, gram cubes. When the two sides balance each other, the total mass of all the unknown masses equals the mass of the object.
Okay, keep reading with the solid, the liquid, and the gas right below there.
Solid. The empty container on the left has a mass of 8 grams. We know this because it takes 8 cubes of balance. Each cube has a mass of 1 gram. Liquid. Now the container has water. More cubes are needed to balance the extra mass. These extra cubes match the mass of the water. Gas. This inner tube has more mass when it's pumped, full of air than when it's flat.
Okay, and the same would be with the balloon for the gas. You blow it up, it's got more. If you have a raft that you would have for your pool, same thing, okay? What I'm trying to think of is common things that you would blow up that you would use. Your soccer balls, basketballs, footballs, all of those, you blow those up, okay, in order for it to work right. Now, they did the solid, and up at the solid on the balance, they put the container in there. And then they weighed to find out how much that container weighed, okay? And they said that it was about 8 grams, because they got 8 of those cubes over there. So that container, empty container, is 8 grams. So then, if you pour water in there, and you've already got the 8 grams here, what you need to do is then balance it out again. And if you put 15 grams in here, okay, if you had a total of 15 in here, and you had the water over here, how much water did you put in?
7 grams.
7, because you would take away, you have 15 total, but you take away the 8 that were there that weighed the container, okay? So what the amount left is just the water, and so there would be 7 grams that are there in water. Do you want to know how this is used? You guys go to Publix, you go to the deli, and at the deli, you go and order some chicken strips, okay? And the chicken strips, you're not buying them by the strip, you're buying them by the pound. So they put a container on the scale, and they find out how much that container weighs. The container weighs 3 ounces. I used to work there, I know. And so what they would do is you put the container on, and then you set the scale at 0. So am I selling you the container? In other words, are you paying for that container? Put it this way, okay? Ethan, you're sitting there with, huh? If you go to Publix and you buy 3 chicken strips, I put them in the container, in the little tray that they have. And then I put it on there, and it says they're 1 pound and 3 ounces. What would the difference be if I took the 3 chicken strips and just put them on the scale?
The container will make it weigh more, so you have to pay more.
Right. But what Publix does is they take out the weight of the container. So instead of just putting the 3 chicken strips on the scale and dirtying up the scale, they figure out how much that container weighs. And when you put it on there, then they zero out the scale. So are you paying for the container?
No.
Then anything that you put in there, it's gonna start weighing it. So then all that you're paying for is the weight of the food that you're getting, the chicken strips in this case. Okay? That's what they're doing with this liquid. You're wanting to find out how much liquid is in there. What's the mass of this liquid? Well, that's the way that they're doing it. You weigh out the container that's gonna hold it, because the liquid doesn't have a shape. Okay? And so when you put something in there, it's gonna take the shape of that object. The water took the shape of this object. When I filled it up, the water took the shape of this object. Okay? If I had some tall cylinders that I was gonna do this in, but I figured I needed some clearer cups so it would show up better. So it took the shape of those. If I did it in the cylinders, it would take the shape of that cylinder. Okay? But if I wanted to know how much, I would weigh the cup first, find out how much that weighs, then put the water in, then find out a balance and subtract from what I did. Okay? All right, on to volume. Emma, nice and loud.
Volume. The amount of space an object takes up is its volume. Volume can be measured by milliliters. You can use a graduated cylinder to find the volume of a liquid. You just pour the liquid into the cylinder and read the volume off the scale at the surface. Solids also have volume. If you put liquid in a graduated cylinder and let a solid object sink in the liquid, the solid takes up some space. The liquid that was in that space is forced to go up. The change in the height of the liquid column tells you the volume of the solid. Gases have volume. In fact, a small mass of gas can fill a large volume. You can measure the volume of a gas using an upside-down, partially submerged, graduated cylinder filled with water. If you blow air into the cylinder with a straw, the bubbles will push some water out. The volume of the water pushed out is the same as the volume of gas.
You guys understand that? Let me go over it. The very simple one is when you have the graduated cylinder and you pour water in at where it goes to, that's how much it is. I do this at home all the time, and the way that I do it is God is giving me some water. Yeah, I know, I'm mixing religion with science. Mrs. Callie, you tell her this, she's gonna love it. Okay? How is God giving me water? Luke?
The rain.
It rained. I have a rain gauge outside. So to find out how much rain came, I put this rain gauge out there. All it is a cup that has on the sides of it, 1/4 inch, 1/2 inch, 3/4 of an inch, 1 inch, 1 1/4, 1 1/2, 1 3/4, 2 inches, and I think it only holds 2 inches. So if it rains and it pours, and I go out there later on and look at it, what am I doing? I'm measuring what?
The volume of the rain.
The volume of the rain, the volume of the water that God gave me that day, okay? So that's one way of doing it. If you're cooking, my wife was cooking rice last night. For every cup of rice, you're supposed to have 2 cups of water. So she gets the measuring cup, she puts in 1, she puts in 2 cups of water, brings it to a boil, then she measures out the rice. The rice is a solid. Very good, you guys are catching on. It's a solid. I can pick up the rice. The water, I really can't pick up. The rice, I can pick up. So she pours a cup of rice, and then she pours it in there once the water's boiling. So she's measuring those. Now, if you can't measure it that way because it's, the rice is small, it's like measuring sand or measuring salt, measuring smaller granule things you can do. But if you got something big, then you put water into something, into a container, a liquid into the container. You drop the solid in. If you have 1 cup of water and you drop in something in there and it goes up to 1.5 cups, how much volume does that solid object have?
1/2 cup.
1/2 cup, okay? I got a hot tub at home. We go out and get in it, and what happens to the water? Ryan?
It goes higher.
It goes higher, because I'm a big guy, bigger than you, Ryan. And what happens is it goes up. If I were to fill the hot tub with water, okay, and then get in, what's gonna happen? It's gonna overflow, okay? So that's how you can measure a solid. Gas is the trickier one, but if you think about this, it'll make sense. What you do is you take that graduated cylinder, fill it, then you put one of these cups. Before you put the cup on it, you put a straw in the graduated cylinder, and one that has that you can bend, has the flexible bend thing that's not gonna crunch the thing. And so you put the straw in, you put this on top, turn it upside down. Then you take the straw and you blow into it. You're blowing gas into that graduated cylinder that has nothing but liquid in it. So you can blow in, 1/2 cup of air in there, and it'll show up as 1/2 cup, okay? And basically what happens is the air goes to the top and it pushes the liquid out at the bottom. That's why you have to have the cup. Otherwise, you're gonna have a mess all over the place, okay? But that's how you would do that, okay? So you can measure with volume, you can measure with mass, and you can look at color. These are the first 3 ways that we're gonna talk about with it. And tomorrow, we'll finish out other ways to describe matter, okay? Good stuff.
It's still going.
It's still going.